Okay, here are your solutions to exercises 1, 2, and 3, the rest of section 4.4. So how many solutions does each equation have? Well, if you're going to, for A, if you're going to take a square root of both sides, you got to include a plus or minus on one side or the other. That was the rule from the beginning. So it's got two solutions. It's got x equals the square root of 10 and x equals negative square root of 10. So 2 is the answer to the question. What about x squared equals negative 10? Well, if you were going to do square roots of both sides, the square root of negative 10 is undefined. There is no number that you can square that will get you negative 10 as a result, because anything squared is always positive. X squared is greater or equal to 0 for any x. So this has no solution. This one, x to the power 6 equals 0. You could take a square root of both sides, I guess, and get like the square root of 0 or the negative square root of, or sixth root of 0. But that's just 0, because the only thing you can raise to the power 6 and get 0 is x equals 0. You could say, if you want, positive or negative 0 if you're doing a sixth root, but positive 0 and negative 0 are the same number. All right, let's look at x to the power 6 equals 10. So you've got this, x to the 6. If you want to undo that, you could undo that with a sixth root, or raising it to the power 1 over 6. But because 6 is an even number, the rule is you've got to include the plus or minus. And you could get an estimate for what this is with a calculator. If you do 10 to the power 1/6, you'll get 1.468. And that's two solutions, because there's the positive one and the negative one. If you want to check that, it's always a good idea to check things, especially in this section where everything's weird. Negative 1.4677799 to the power 10, the power 6. Hopefully this comes out to be 10. And it does. 9.999989 is basically 10. So this has two solutions. X to the power 3 equals 27. If you do an odd numbered root, which is what we need to do here, the third root, do not include the plus or minus. So it's just going to give you x equals 3, which is one solution. Okay, x to the power 3 equals negative solution. Same idea applies here. Wait, what did I say? X to the power negative, my mouth isn't working today. X to the power 3 equals negative 27. It looks just like this one. It's just we got a negative 27 there. And the cube root of negative 27 is just negative 3. And that's only one number, so there's just one solution. And you can see what's different about A and B. Like A has two solutions, B has no solution. Whereas, and that's when you had an even number and a positive or negative number on the other side, an even power. Here you have an odd power, 3, and a positive and negative number on either side, but there's just one solution for each. So sort of a compare and contrast sort of exercise here. Okay, now x to the power 1/2 equals 4. You can square both sides, and you'll get 16. So that's just one solution. Negative 16 doesn't work, because if you were going to plug in x equals negative 16 into that, that's going to be the square root of negative 16, which is undefined. Not allowed. X to the power 1/2 equals negative 4. You could still square both sides here. And x to the 1/2 to the power 2. Well, 1/2 times 2 is 1. So that will just give you x to the power 1. And negative 4 squared is 16. So you get x equals 16 here. But that is an extraneous solution because 16 to the 1/2, if you check it, is that equal to negative 4? No, 16 to the 1/2 is the square root of 16, which is 4. So that is not a solution. This has no solution. It just has one extraneous solution. All right, with this one, if you have an odd number in the denominator, how does that make things different? Well, if I cube both sides to cancel that out, because 1/3 times 3 is 1, you're just going to get x equals negative 4 to the power 3. Let's write that out. Two of these are going to become positive. You'll get 16 times negative 4 comes out to be negative 64. And let's check that because we might have introduced extraneous solutions. Remember, that's what this rule says. Whenever you square both sides of an equation or raise both sides to any even power, always check your answer. Well, we didn't do an even power, we did an odd power, but let's just see what happens if we check this. If you have negative 64 to the power 1/3, is that equal to negative 4? Well, this is going to be the same thing as the cube root of negative 64, and that is negative 4. You can check it with your calculator if you're not sure, if you forget how this stuff works. So 1/3, I meant to say. So yeah, negative 64, when you plug it into the left side, does give you negative 4. So that works. So this has one solution. All right, so those are the answers for exercise 1. If you got those right, give yourself a pat on the back because that stuff is tricky. All right, let's look at the solutions for exercise 2. These ones are weird. This should definitely be a challenge. You maybe haven't done equations quite like this. So if you got a little stuck, or if you did some stuff and you don't know how much it makes sense, this is a good thing to watch. So what I would do here is say, I have like this x to the negative 2. I guess I would say, what does that really mean? And what it really means is 1 over x squared. So I'm going to write this as 54 over x squared. And if you have an equation like this, how would you go about solving this? Well, what I would do is try to get all of the x's on one side. And also try to get x's out of the denominator. Having x squared in the bottom of this fraction is ugly, right? So the way to cancel out that fraction is to multiply both sides by x squared. So you get x squared times 2 times x. That ends up being 2, well, x is like x to the 1, right? So 2 plus 1 is going to be 3. So we have a total of 3 copies of x over there equals 54. And before you want to do a square root or anything, or a cube root, you want to divide both sides by 2. Because the cube, if you're going to do a cube root first, don't write this down, this would be a mess. You'd have to do the cube root of 2 and the cube root of x cubed separately, and I guess it would be okay, but most people make mistakes when they try to do it that way. So the 2's are going to cancel out. You'll get x cubed equals 27, And hey, we know what the solution to that one is. Did we just do that? Yeah, x cubed equals 27. The solution is x equals 3. So I'm just going to copy and paste this work here. So the solution is x equals 3. All right, this one is also a little weird. Again, the trick is if you have L squared in the denominator, it would be nice to cancel that out. And the best way to cancel out a denominator is to multiply both sides of the equation by that denominator. So that's what I'm going to do. I'm going to take 16 minus 1 over L squared, multiply the whole thing by L squared, and then on the other side, we're going to take 0 times L squared. And 0 times L squared is just 0, so that was easy. Over here, we're going to have to distribute it. You're going to have 16 times L squared. And then L squared times 1 over L squared is just 1. That cancels out. Okay, so now I want to get the term with just L squared by itself. I'm going to add 1 to both sides. It's going to look like 16L squared is equal to 1. Let's divide both sides by 16. You get L squared is 1/16. So we want to take a square root here. But what is the rule for taking square roots? Let's go back up to the notes. This rule here, whenever you take a square root of both sides, always include plus or minus on one side. So we got to do that here. Because the square root of L squared will cancel out. On the other side, we have a plus or minus square root of 1/16. And the square root of a fraction is a little weird, but it's basically just going to be the square root of 1 plus or minus square root of 1 divided by the square root of 16. The square root of 1 is just 1. The square root of 16 is 4. So you have plus or minus 1/4. And I encourage you to plug that in and check in the original equation, but I think it's right. Okay, here, how can you combine these x's? Like that's what I did with example A. Maybe you could, but let's think back to chapter 3. We solved a bunch of equations like this that have x squared plus 4x equals 0. There's a few ways to do it. You could use the quadratic formula. You could use factoring, I think is the easiest way here, because we've already got 0 on one side. So this is quickly factorable, if your factoring skills are still sharp. We're going to have x times x plus 4 equals 0. And if either of these two things is equal to 0, that will make the whole thing equal to 0. This one will give you x equals -4. Okay, so those are the solutions to that. Let's go on to exercise 3. So let's solve each of these equations in this last example again, but this time by graphing on a calculator or Desmos.com. So here's what I'm going to do is go to Desmos here. And we want to do, let's see, 2x and 54x to the -2. So the way to solve this by graphing is to, on Desmos, delete the stuff I had before. Need to make the scale reasonable. So we have y equals 2x, and we want to graph y equals 54, x to the power -2. All right, so yeah, you can see where they intersect here is at x equals 3. 3 is the value of x, in other words, that makes both of the y's come out to be y equals 6. So if we were going to check this here, if we plug in 3 in the left and 3 on the right for x, you'd hopefully get 6 equals 6. So it is a solution. And if you want to make sure they don't intersect at any other places, like what if there was actually 2 solutions and you forgot to get one of them or something, you might want to zoom out a little bit and just make sure that you can see these are never going to meet anywhere else, and they don't. So that's good. Uh-oh. That's not what that was supposed to... Okay, there we are with that one pasted in. Now let's look at the other one. For this one, we're going to graph y equals 16 minus 1 over... I guess we could use L. Desmos might freak out if I try to use L as a variable. Let's see what happens. Oh, it looks like no problem there. And we're also going to graph y equals 0. So we want to see, where do these intersect? What are the values of L that make it so these meet? And I can see this happening here. So I'm kind of zooming around to get a better picture for what the red graph looks like. And it's kind of a weird graph, but there's one intersection right here at L equals 0.25, 0.25, another one over here at L equals negative 0.25. So those are the 2 places where those intersect. And that's 0.25 is another way of saying 1/4. So that sounds good. All right, let's look at this one. We're going to graph y equals x squared plus 4x and y equals 0. Okay, and I need to mess with the graph a little bit. Yeah, we can see at x equals negative 4 right here, and at x equals 0, it looks like those meet, which is what we wanted. So that sounds good. All right, so yeah, it's always a good idea to practice graphing stuff. You can learn a lot from a graph, of course, and it's also a good way to check your answers, and you might develop a better understanding for why these weird things happen in this section. Like, why is it that some of these have no solution, some have 1, and some have 2? I think a graph is another way to help see how that works. So anyways, that is section 4.4. Good luck with the homework and the quiz, and I'll see you in the next video. Take care.